to another one of Armagh Observatory and Planetarium Science at Home videos. Today we're doing 5 minutes with Professor Alyssa Goodman, and she is coming to us from Harvard University. And if you don't know where that is in Cambridge in Massachusetts. So hi, how are you? How are you doing today, Alyssa?
Hi, Heather. I'm great. It looks like fun.
I can't wait to start picking your brains. So the format of this interview is we're going to ask you 5 questions, and basically we're going to try and do this in about 5 minutes. So pressure's on a little bit, but we do like a chat. So if we go over 5 minutes, that's fine. So
Okay.
The first question I have for you today is, what are the top 3 things about working in Harvard?
I would say the people, and the people, but that would be corny. So I'll say the people first. We have lots and lots of smart and eager and very creative people. The second thing would actually be the history of the institution and sort of knowing what's happened at Harvard, not only in astronomy, but more broadly in terms of education and research in the United States and to some extent in the world. So that's definitely something that crosses your mind when you walk through the beautiful buildings at Harvard, which of course I can't do right now. And then I would say the resources. So not just the human resources, the people, but the financial resources. And so Harvard, again, until very recent times, is a very well endowed institution, both in terms of money and facilities, and also the people who support Harvard and make all that possible. And so when we want to do something, scrounging around for resources is only a smaller part. And we realize how incredibly lucky and privileged we are for that.
Oh, that sounds brilliant, and it's great to have that resource at your back, definitely. So my second question is, what is your proudest achievement to date?
In astronomy.
In astronomy, yes. Yes.
Well, I'm going to give you kind of an odd answer. So I do a lot of work on data visualization. And so there are 2 pieces of software that I've been involved with, one that I lead and one that I've just been very involved with. And they've enabled a lot of results, including our own. So our most recent interesting science result is about something called the Radcliffe Wave, and maybe we can talk about that later. But if you talk to anybody who's involved in that project, they'll tell you that the software that made that possible is all relatively recent. And so the one software package that I love the most is called Glue. And it's for connecting different data sets and then connecting different visualizations of those data sets. And then most recently, we've also been focused on connecting in different software tools. And one that especially amateur astronomers and professional astronomers might be familiar with is the other piece of software I've been very involved with, which is the Worldwide Telescope that was originally made from Microsoft Research, but is now an open source project under the aegis of the American Astronomical Society and usable in planetaria everywhere. And so there are now these things called plugins to Glue, like Worldwide Telescope, and also Open Space, which can also be used in a planetarium. So yes. I guess making that software and then making it possible for so many people to use it to make discoveries would be my proudest achievement. But I've had many collaborators on definitely. That software and on everything else.
And like the Armagh Observatory and Planetarium will be getting involved with the Worldwide Telescope at some point as well. We had a couple of emails about it yesterday, so I'm really looking forward to that. And it's exciting to know that you've worked on that. That's fantastic. So getting down to more of the astronomy and the research that you've been doing, one thing that I know everyone will want to know, and it's probably something that can be a little tricky to explain, is what exactly is the interstellar medium?
It's everything that isn't a star and that is not exotic matter. Okay, although you could include exotic matter. Wow, that's a hard question. It's everything that's not a star between the stars. That's the easiest way to say it. So it's gas and little solid particles called dust, but it's also ionized gas and energetic particles and exotic particles that some people would or wouldn't count. If there's dark matter in the disk of the galaxy, is that part of the interstellar medium? And the answer is traditionally no, but actually yes. So let's just go with everything between the stars.
So definitely something that needs to be explored a lot more. As part of your research, I know you talk about how gases make new stars, and so I want to know, how do you actually identify different gases in space? That must be quite tricky.
Finally, a question that's relatively straightforward. So the answer is actually spectroscopy. So some people think of spectra as, the rainbow that you see from a prism, but that's a teeny, teeny piece of the whole electromagnetic spectrum of radiation. And so we use that whole electromagnetic spectrum, and different elements and different molecules have different signatures, spectral signatures that you can see at different wavelengths. And so the interstellar medium is very cold, most of it, not all of it, but a lot of it is very cold. And it turns out, for interesting reasons, that radio astronomy is good at seeing things in cold regions. And so a lot of what we do in terms of identifying the properties of the gas is in the radio telescope world. And in fact, again, for reasons we won't go into here, you get high resolution in measuring the motion of gas in the radio regime. And you do that by using the Doppler effect that a lot of people will be familiar with, the motorcycle going by example, and the sound sounds different when it's toward you or away from you. And so you get redshift and blueshift at, electromagnetic waves. And so that gives you the ability to measure the velocity of the gas. So not just what it is, but we can actually measure where different gases are, how dense they are, from how much emission there is, essentially what temperature they're at from the properties of different lines, and then also how they're moving. And so we can actually do a lot, all with spectroscopy. And one fun fact is that astrophysics, the word astrophysics, actually came from when the astronomers weren't so sure about spectroscopy, and they needed another name for astronomy with spectroscopy, which was astrophysics.
I did not know that. That's really, really interesting. And that sounds very, very fascinating. I know some of the kids that will be watching at home will be learning about the spectrum at this point, and what you've just explained will be very helpful for them. And finally, what are you currently working on?
Sure. Well, I mentioned the Radcliffe Wave before, and so it turns out that using this visualization software and all kinds of probes of the interstellar medium, including of gas using spectroscopy, like we just mentioned, but also of the three-dimensional distribution of dust, bigger particles than what you'd call gas. We managed to piece together a lot of different so-called molecular clouds that we knew were kind of near the sun, but we didn't quite know where they were. And by near the sun, I really mean very far away, but locally near the sun compared to the galaxy. And it turns out that they form a gigantic interconnected sine wave that goes in and out of the plane of the galaxy. And for reasons people can read about online, we named that the Radcliffe Wave. And like I said, we use this software, and we use data from the Gaia telescope, the European billion star mission. It's a long story how, but anyway, we managed to do this, and we've also managed to find a lot of other very long, weird structures in the plane of the galaxy. And all of the statistical reconstructions we're trying to do seem to indicate that the Milky Way may not be the flat spiral disk we once thought it was. It's something else. It's very wavy in the outside. Spiral arms might not be so good. And so we have a big project going on now that we call knitting together the Milky Way. And there's a student, Catherine Zucker, who you should also interview if you want to know more about that.
Definitely.
Because her quest is to knit together sort of radio and optical and infrared information and a lot of statistics and a lot of data science into a coherent three-dimensional picture of our own galaxy, which your audience will know is the hardest galaxy to map out because we're inside it. It's a lot easier to see galaxies outside our own.
Oh wow, that sounds so fascinating. You guys are doing such amazing work, and I'm jealous. You have a lot to play with. Professor Goodman, thank you so much for taking time out of your day to come and speak with us. We really appreciate it, and I hope you have a great day. And please continue to do your research and update us when you can, because I'm sure everyone wants to know what's going on. Thank you again, and have a great day, everyone.